Hi everybody, hope you're okay. I know yesterday's lesson was quite long because we needed to get through all that, but hopefully today's will be a little bit shorter than that. I'll try and make it a bit shorter than usual. Okay, so starters, we're recapping what we've been doing last week. So we'll multiply out and simplify. These were the kind of questions you had for your assignment as well, which I've marked some of, and if I think you need to do it again and watch more videos, I've said so. Okay, otherwise I've given you your marks back. All right, so let's just get on with these. Multiply out and simplify. Now remember, when you've got a squared, it means multiplied by itself. So this means 3x minus 1 times 3x minus 1. So it doesn't really matter, of course, what method we use for multiplying these out. I'm just going to go FOIL, I think, for this. So remember, that's first, outside, inside, last. So first things in the brackets, 3x times 3x is 9x squared. 3x times negative 1 is negative 3x. Then insides, negative 1 times 3x is negative 3x. And then negative 1 times negative 1 is positive 1. So altogether, remember, it's very important that you simplify once you've done this. So we get 9x squared minus 6x altogether, and then plus 1. Okay, and this one, same sort of idea. I'm going to use lines this time. So this line first gives us 4t. Now be careful with this. It's t times t squared, so it's t cubed. Second line, 4t times negative 1 is negative 4t. Next line, negative 3 times t squared is minus 3t squared. And then the last line, negative 3 times negative 1 is plus 3. So actually in this case, because I've stuck this t squared in here, there isn't anything that's going to simplify. There are no like terms here. So let's just write it, oops, don't know how that happened. Let's just write it in descending powers of t. That means you start off with the highest power of t. So that's 4t cubed. Then you need the next highest power of t, which is this one. So we've got negative or minus 3t squared. Then we've got the t's and then the numbers. Okay, so fairly straightforward. If you're still struggling with this, all I can say is you need to practice it more. Okay, there's several different ways I've given you of doing it. You stick to the one that works best for you, but make sure that you are doing it and doing it correctly. Okay, now we're recapping what we did yesterday here. The highest common factor of 8g squared and 12g cubed. Right. So, first of all, let's look at the numbers. Think about the factors of 8 and 12. So the factors of 8 are 1, 2, 4 and 8. The factors of 12 are 1, 2, 3, 4, 6 and 12. Okay, so the common factors are 1, 2 and 4. So the highest common factor is 4. So the highest common factor of these two terms, the number part of it is 4. Now we need to have a look at g squared and g cubed and think what's the biggest thing that we can multiply by to get these. So we've got our choices really, when we're looking at these, you're probably going to think along the lines of g squared and g cubed. Okay, so let's think about g first of all. See if we can multiply g by something to get both of these. Okay, so g times g is g squared, and g times g squared is g cubed. So that is a common factor. Okay, so we've got g squared next. So we think, can we multiply g squared by something to get both of these terms? Well, g squared times 1 is g squared, so that's fine. G squared times g is g cubed. So that one is also a factor, a common factor. All right, let's think about g cubed. Right, can we multiply g cubed by something to get g squared? And the answer there is we can't, okay, because g cubed isn't a factor of g squared. Okay, we could do g cubed times 1 to get that, but we can't do g cubed times something to get g squared. So g squared is the highest common factor. So the highest common factor of those two terms is 4g squared. Okay? All right. Remember, we use that when we're factorising. Okay, so on to factorising then. We looked at... That's happened again, that's strange. We looked at factorising expressions using common factors. We did that yesterday. Okay, today's job is factorise using a difference of two squares. So, we need to look at the different words in this. This is called a difference of two squares. It's a phrase you need to learn, okay? And first of all, we need to know what's meant by squares, okay? Now, a square is something that is the answer when you square something, okay? So, for example, because, let's say 10 squared is equal to 100, then 100 is called a square number, okay? Because something squared gives you 100, okay? X squared is a square because x squared gives you it, okay? If you can square something to get it, then it's called a square, right? So it's best to look at examples, I think. So first of all, which of these terms are squares? Well, we can see that x squared is a square, okay? Because you square x to get it. So that is, it's just the same as x squared, isn't it? So that one is a square. All right, what about 16? Can you square something to get 16? And the answer is you can. You square 4, don't you, to get 16. Remember, 4 squared means 4 times 4. Okay, so if we combine these two, it must be the case that if x squared is a square and 16 is a square, it must be the case that 16x squared is also a square, okay? So like we were looking at before, we're going to mix up the numbers and the letters and look at them separately though. So 4 squared is 16, x squared is x squared. So what we can say is that if you squared 4x, you'd be doing 4 squared and x squared, so that would give you 16x squared. So that one is a square as well. Okay, on to the next one. So is 5 a square? Well, it's not, because 2 squared, remember, is 4, and 3 squared is 9. So it must be a number in between 2 and 3 that would give you 5 if you squared it, and we don't have any whole numbers in between 2 and 3. So 5 isn't a square, okay? In the same way, 3 is not a square because you can't square something to get it, and t is not a square either. So that one definitely not a square. Right, 9m. Okay, 3 squared is 9, as we just said up here. So the 9 bit of it is a square, but the m bit of it isn't. Okay, so we don't have something squared that gives us m squared. That gives us m, sorry. So this one is not a square because it has to be both bits of it. And then the last one, 25 is 5 squared, so that's fine. And v squared is v squared, obviously. So if you square 5v, you get 25v squared. So that one is a square, okay? So terms that are squares are ones where if there's a number in it, that the number is a square number, and that the letter term has to be squared as well, okay? Has to be something squared. So you can see that in order to be able to do this properly, we're going to need to learn our square numbers, okay? So this is a job that I need you to do. You need to learn that 1 squared is 1, and that 2 squared is 4, and etc. So you need to learn all of these square numbers. You need to know both the right hand side and what squared gives you that, okay? So you will know some of them anyway. whichever ones you don't know, please make an effort to learn them. I'll just write them all down here. Not all of them, obviously, because I couldn't. 9 squared, 81, 10 squared, 100. Right, if you can learn those, then that's ideal. What would be even better, so we need to learn the right-hand sides of these particularly, but we need to know what squared gives you those. And even better than that would be if you can learn the next few as well. Okay, if you can do that, that's brilliant. So that would be 11 squared is 121, 12 squared is 144. You maybe know those already. You probably won't need the next ones, but if you've got a head for figures and you're able to learn them, then you might as well. Okay, so remember, it's the right hand sides that you need to learn. Okay, so it's these numbers, but you need to know what squared gives you those, but you need to be able to spot them. Okay, so that's one job, is to learn, oh, not with a highlighter, learn your square numbers. Okay, so we'll see in a moment why we need to do that for our difference of two squares, but the next bit, I need to make that go away. So the next bit that we need to think about is difference, okay? And then we'll realise what this all means. So difference, if I asked you to find the difference between two prices or the difference between two numbers, you're going to subtract them, aren't you? If I asked you to tell me what's the difference between £18 and £25, you would do 25 take away 18, so the difference would be £7. Okay, so if you're asked to find a difference, it means you're subtracting. Okay, so that's a really important thing. So to spot a difference of two squares, what it looks like is something squared take away something squared. Okay, so this is our rule for factorising a difference of two squares. So a difference of two squares, you need to be able to spot it. So if it's a squared thing, take away another squared thing, then it is a difference of two squared. It has to be take away, it has to be two terms, and they both have to be squared. Okay, if you've got that, then we can factorise it without any worrying about common factors or anything. If it just looks like that, we can say that that factorises into two brackets, and the two brackets are a plus b times a minus b. Okay, so whatever squared gives you the first thing. Oop, didn't mean to do that. Funnily enough, meant to be a highlighter. So whatever squared gives you the first thing, then that thing goes there. Okay, whatever squared gives you this, then they go in the end of the brackets, and you've got one plus and one minus. Okay, let me just prove that to you by multiplying it out. So if we've got a plus b times a minus b, and we were multiplying that out using the techniques that we've been learning last week, we've got a times negative b is negative ab. Oh, sorry, I missed out the a times a, sorry. It doesn't matter what order you do things in, but let's stick to what I've been showing you here. So a times a is a squared. A times negative b is negative ab. B times a is also ab, but it's positive ab. Remember, ab and ba are the same thing, because when you're multiplying, it doesn't matter about order. And we've got positive b times negative b, so that's minus b squared. Okay, so look here, what we've got is a negative ab and a positive ab, so they cancel each other out. So all we're left with is a squared minus b squared. So we can see that this rule works. Okay, so you need to learn this rule, that when you've got something squared, take away something else squared, then the thing that's squared in the first one, you put in the beginning of your brackets, thing that's squared in the last one, you put them in the ends of your brackets, and then you have 1 plus and 1 minus. Okay, so we're going to just practice that a little bit just now, and then that'll be us done for today. Okay, so let's pick a nice colour. Let's, okay, use that one for a change. All right, so first of all, we need to check if it's a difference of 2 squares before we go ahead and just factorise it willy-nilly. So 16 is 4 squared, and x squared is obviously x squared. Okay, so we need to make 2 brackets. So the thing that's squared here goes in the beginning of the brackets. The thing that's squared here goes in the end of the brackets, and we need 1 plus and 1 minus. Okay. Next one. I'm not even going to write anything underneath these because we can see what's squared. Okay. So we've got a squared thing, take away another squared thing. So the thing that's squared to give you m squared goes in the beginning. The thing that's squared to give you n squared goes in the end. And then 1 plus and 1 minus. Okay, next one. So let's see, what squared gives us 4y squared? So think of the number that's squared to give you 4, so that'd be 2 squared. And then y squared is y squared. So that's 2y squared. 25, remember, is 5 squared. So what we've got in our 2 brackets is 2y and 2y, 5 and 5, and a plus and a minus. Okay, so this is factorising. Now, what I wanted to show you was actually this works even if you've only just got numbers. You wouldn't use it for that, but I just want to show you that it does. Okay, right, first of all, 25 take away 9 is 16. We know that. Okay, let's just see if a difference of 2 squares works though, because this is 5 squared and that's 3 squared. So we could rewrite 25 take away 9 as 5 in the front of the brackets, 3 in the end of the brackets, and a plus and a minus. Okay, so we've got 5 plus 3 is 8, and 5 minus 3 is 2. So we put our 2 there, and 8 times 2 is 16. So it's just to prove that it works even if you've only got numbers, because remember 25 take away 9 is 16. Okay, so on with the algebra ones then. 3 more to do, then we're done. Okay, so we need to look, is it a difference of 2 squares? So first of all, well, yes it is, because 16 is 4 squared and m squared is m squared. So that one's 4m squared. 9v squared, well, 9 is 3 squared and v squared is v squared. So there are 2 terms that have been squared to give us the 16m squared and the 9v squared. We can see it's a difference because of the minus in the middle. So we can set this up as 2 brackets again, with 4m in the beginning of the brackets, 3v in the ends of the brackets, and a plus and a minus. Okay? Then, so you should be spotting these by now, that the thing that's squared to give us 4 is 2. So that's 2u squared. The thing that's squared to give 49 is 7. So these 2 brackets are 2u in the beginnings, 7's in the ends, and a plus and a minus. Okay, and then the very last one for today. It is a difference of 2 squares because 81 is 9 squared. So that's 9z squared. 4 is 2 squared. So 9z goes in the beginning of the brackets. 2 goes in the ends of the brackets. And we've got a plus and a minus. Okay, now I actually normally do z's with a wee line across to stop them looking like 2's. So you need to be really careful in a question like this, especially one that's got 2's and z's in it, that you make your z's and your 2's look different. Okay, So that's us for today on difference of two squares. I'm going to give you some practice questions to do on this, and really for difference of two squares it's just a case of spotting that that's what it is, working out what's squared to give you both terms, and then constructing your two brackets. Okay, well I will see you tomorrow. Well done.